Okay, this lesson is actually a very brief one, and it's not so much a lesson as sort of pointing you in the right direction here. So we talked about transformations, sliding, shifting, expanding, shrinking graphs on a coordinate plane. We looked about symmetry, reflections, and the different types of geometric symmetries that a graph could have on a coordinate plane. But one thing that's a great starting point in order to answer questions like that is to just know what types of functions are. So on pages 218 and 219 of our text, there's what they call like a function gallery. And they start off with just giving you a few basic examples of just some functions that if you have a good idea of what these graphs look like, you're off to a great start in transforming them or answering questions about them. So they look at three types of linear graphs, just a constant function here on the left. Gives you an example of the graph of y equals 4, f of x equals 4, domain, range, and then it talks about it whether it increases or decreases and what type of symmetry. What they call the identity function is the simple linear equation that you would remember as y equals x, the diagonal line that goes right through the origin. And then, of course, you can make a linear equation a little more complicated with your slope and y-intercept changing, your mx plus b. And so they give the example 3x plus 2, and then with a line, the domain and range, as long as it's not horizontal or vertical, the domain and range is always all real numbers, and it'll either always be increasing or it might always be decreasing. The other six that they give you are functions that we've talked about probably in some capacity or another already in the course, or we definitely will later on, and that's I'll kind of start sort of in the upper middle here, the square function, or y equals x squared, and then its inverse, which we're going to talk about inverses later in the module. The inverse of squaring is square rooting, and so there's your square root function. Down here in the lower level, sure, we've got the same thing. We've got the cube function, y equals x cubed, and then the inverse of that, y equals the cube root of x. You might notice a relationship on the graph of the cube and the cube root and the square root, and if you kind of see that visually, you're up for a good head start when we talk about inverses and their relationship. And then two other special functions we talked about earlier in this module were the absolute value function, and that's just a graph of a v. There's your domain, range, where it increases, where it decreases in your symmetry. And then that other special function, the greatest integer function, which is also known as the step function. So take some time to study these and get a good idea about their behavior, how they look, and you will be off to a great start in working with them.